Hey folks, this is going to be the first of the videos in section 8.1. I will be doing several videos, at least two, but probably more than that. Okay, so this particular discussion is going to be dealing with the law of sines. If you remember back in chapter 5, we learned how to solve triangles. Remember that solving triangles is where you just simply find all of the missing pieces of a triangle. You've been given a certain amount of information and you have to find all of the missing pieces of information. The difference is that in chapter 5, we only worked with right triangles. And so in chapter 8, we're going to be dealing with non-right triangles. And the very first thing that we're going to see here is the definition of a non-right triangle. A triangle that is not right is actually called an oblique triangle. So when you hear me use the word oblique, it just simply means it's a triangle that does not have a right angle. All right, this first video is only going to be an introduction to solving oblique triangles using the law of sines. There will be no examples in this particular video, just simply filling out some blanks. So let's talk about, first of all, some symbolization that we'll be using. We'll look at side, side angle, and side, side. And so basically what's going on here is if you've got two sides and the included angle, that's why the A is between the two S's, two sides and an included angle are equal to the two sides and included angle of another triangle, then we know that these two triangles are exactly the same thing. They're congruent to each other. ASA just simply means that the side is between the two angles, and then SSS means that I have three sides. So recall that a triangle can be solved. Again, that just simply means that all of the angles and all of the sides can be found. If you know at least one side and any other triangle measure. So you have to know at least one side. Other than that, if you're given any other, and this actually should be any other two triangle measures, you have to know a total of three measures. And so if you know one side and any other two triangle measures, then you are able to solve the triangle. There's going to be four possible cases for solving obliques. Case number one is where we have two angles, and one side known. Now, my side might be not between the two angles, or my side might be between my two angles. Either way, I have two angles and one side that I know. I can solve this particular oblique triangle. Case number two, this is called the SSA triangle, or the ambiguous case. This is where I know two sides and I know the angle that's not included between those two sides. This is called the ambiguous case, and here you might have 0 solutions, you might have 1 solution, or you might have 2 solutions. We'll cover this later in section 8.1. This is going to be the second half of section 8.1. Case 3 is where you know two sides and the angle between. So both case 2 and case 3, you know two sides and one angle. The difference is that here the angle is not between, here the angle is between. So when I know two sides and one angle where the angle is between, then I can solve. And then case 4 is where I know all three sides. Just a side note here, if you know all three angles, you don't know any sides at all, you cannot solve this particular triangle because my triangles may be different sizes. Let me just show you a really quick example of this. Let's take an equilateral triangle where all three angles are 60 degrees. So an equilateral triangle, this is a very bad drawing, sorry about that, where all three angles are 60 degrees, might have side lengths all of 1 unit. But then I might have another equilateral triangle, again, where all three angles are 60 degrees, but this time maybe my sides are all 10 units long. These are obviously not the same triangle, so if I know the three angles, I cannot automatically find what the three sides are. We're going to use the law of sines in section 8.1. In section 8.2, we will progress to the law of cosines. So the law of sines is going to be used for case 1 and case 2. The law of cosines will be used for case 3 and 4. So the law of sines is simply going to be a ratio of some values here. So let's take a look. My ratio is going to be side A to sine of angle A is equal to side B to sine of angle B is equal to side C to sine of angle C, trying to make it very clear what is a side and what is a sine, trying to be clear on that. Now, what this is saying then is that the lengths of the sides are going to be proportional to the sine of the angles that are opposite them. You can take all three of these fractions and flip them over, and this is going to be alternative method of using the law of sines. And basically what you need to remember, which one do you need to use? Whatever's unknown should go on top. It'll just make your life a little easier if you do that. It's not an absolute necessity, but I find that when the unknown is on bottom, students tend to make mistakes. All right, so for the two cases that we use for the law of sines, case number 1 is where I have 2 angles and a side. And so what you need to do is you want to find the third angle, and you're just going to use the angle sum formula. You know that all angles in a triangle add up to 180. So you'll just take the 2 angles that you do know, subtract them from 180, and then you can find your missing sides using the law of sines. So step number 1, find your third angle. Step number 2, find your sides using the law of sines. Case number 2 is what we'll do in the second half of section 8.1. This is the ambiguous case. So if this doesn't make a lot of sense to you, that's totally okay for right now. Wait until we use the discussion later on in this section. This is where you know 2 sides, but the angle that you know is not included. It's not between the 2 sides. The simplistic list of steps here, there's more to it than this, but the simplistic list is that the first thing that you want to do is you want to find the angle that you can using the law of sines. And the second thing that you want to do is to find the remaining angle just by simply adding the 2 angles that you have and subtracting from 180. And then step 3, find the remaining side using the law of sines. If there are 2 triangles, because there might be none, 1 or 2, if there are 2 triangles, then you'll just simply repeat steps 2 and 3. All right, I'm going to stop the video here. This was just simply an introduction to the law of sines. The next video is going to be an example video using the law of sines for case 1.